For months, one name has kept astronomers awake at night. It is not a new star or a dying galaxy. It is a small visitor drifting in from deep interstellar space, a visitor now known as 3I Atlas. When it first appeared, most scientists treated it as another frozen fragment moving through the dark. Nothing unusual, nothing worth losing sleep over. But that changed the moment the James Webb Space Telescope locked onto it. JWST collects light with a sensitivity far beyond any telescope before it, and NASA has confirmed that Webb can detect faint thermal emissions from distant objects. Yet what it saw on 3I Atlas did not match anything natural. The glow came from inside, not from sunlight bouncing off ice. Every 4 hours, the light pulsed again, steady and controlled, almost like a heartbeat coming from a solid object. At the same time, radio stations on the ground logged repeating narrow signals that matched the exact timing of the pulses. The pattern was too precise to ignore. It no longer felt like a distant rock drifting past our sun. It felt like something aware of its own presence. If an interstellar object can answer, can change its rhythm, and can adjust its own path, then what kind of intelligence are we standing in front of? When 3I Atlas first appeared in July of 2025, it looked like the kind of object astronomers see every few years. A faint line of ice coming in from interstellar space, cold, quiet, and moving on a path that would carry it past the sun before it disappeared forever. Reports describe it as nothing more than a drifting shard, the third interstellar visitor ever recorded, but still too small and too dim to spark any real interest. Most teams logged the detection and moved on. Space is full of debris, and no one expected this piece to be any different. The mistake was assuming it would behave like everything that came before it. For weeks, 3I Atlas stayed quiet, slipping through the outer solar system with no visible changes. Then James Webb turned its mirrors toward it, and the story shifted. At first, the numbers coming back from the telescope confused researchers. The brightness curve showed a slow climb that did not match sunlight. Webb had seen other faint objects brighten before, but this rise did not follow the thermal models used for comets or icy bodies. It seemed to lift from within, as if the glow belonged to the object itself. Then came August 18th. During what should have been a routine observation window, 3I Atlas increased its brightness by 40% in just 1 hour. No natural visitor had ever done that. The rise was too clean, too sudden, and too focused. Teams on the ground checked for instrument errors, but every telescope watching the object reported the same change. While scientists tried to explain the light, a second anomaly appeared. The object adjusted its path. Interstellar bodies follow gravity and nothing else. They do not drift off course on their own. They do not shift their angle in real time. Yet the trajectory plot for 3I Atlas bent by a measurable amount, not because of a collision or a burst of gas, but because the object changed direction as if responding to something. That moment forced many to reconsider what they thought they were looking at. From that day forward, the pattern held. Every new observation pushed the object further away from anything that could be called natural. The glow, the pulses, the path changes, all of it built a picture no one wanted to accept. The third interstellar visitor was not acting like a visitor at all. It was behaving like something with a plan, and this raised a new fear. If this was the third object to enter our system, how many came before it without being noticed? The first clear sign that something was wrong came from a light curve. When James Webb recorded the glow of 3I Atlas in its early passes, the pattern looked too perfect to ignore. Natural objects flicker. They scatter sunlight in ways that depend on rotation, shape, and distance. But this one pulsed. The rise and fall repeated at clean intervals, almost like a machine distributing energy in steady waves. Every 4 hours, the pulse returned, and each return carried the same strength, the same timing, and the same smooth shape. Nothing in deep space behaves with that level of discipline. When the spectral data arrived, the confusion grew. Webb's instruments separated the wavelengths the object was giving off, and the result pointed to heat that came from inside the body. Comets produce heat when they approach the sun, but that heat always forms a halo of gas and dust. It always shows the fingerprint of melting ice. 3I Atlas showed none of that. The warmth remained centered. It did not spread outward. It did not deepen when sunlight hit it. The temperature held steady as if something inside the object was powering the glow from a hidden core. Models failed one by one. Astronomers tried to match the light to reflective surfaces, but the brightness curve refused to flatten. They tested the possibility of trapped solar radiation, but the timing did not shift with distance. They checked for surface fractures that could release bursts of vapor. Yet no plume appeared in any telescope image. The object released no dust trail at all. The more scientists tried to explain it, the more the data forced them back to the same unsettling truth. The light did not belong to ice or rock. It belonged to a controlled source. Then a new detail pushed the story into stranger territory. As the object rotated, the pulses changed ever so slightly depending on its orientation. When the side facing deep space turned toward the sun, the rhythm stayed stable. But when 3I Atlas completed its rotation and the brightest side pointed directly toward Earth, the pulses intensified. The peak rose higher. The signal sharpened. It was as if the object sensed when it was aligned with us. Teams across the world ran comparisons and found the same pattern. Webb confirmed the timing. Ground telescopes confirmed the rise in amplitude. For the first time, astronomers had to consider that the glow was not only internal but responsive. It brightened when looking at the one place in the solar system capable of watching it closely. It was the kind of detail no one expected to see, and it left a chilling question behind. If the light strengthens when 3I Atlas faces Earth, what exactly is it trying to show us? The light was strange enough, but the real shock came from the radios. Soon after the brightness spike, several observatories across the world reported a narrow carrier wave coming from the same patch of sky where 3I Atlas was moving. A carrier wave should drift when it crosses cosmic distances. It should wobble or fade as it passes through dust, magnetic fields, and background noise. This one did not. It held a clean line, steady and sharp, like something designed to stay intact. When researchers broke the signal apart, the pattern grew even stranger. Using Fourier analysis, they found the waves separating into repeating blocks. Natural sources do not organize themselves that way. Noise from stars or plasma storms spreads out like static. Pulsars produce regular beats, but their signals never divide into structured segments. The blocks here looked intentional. Some teams describe them as the kind of spacing you see when information is being packed or shaped by rules, almost like the pauses between spoken sounds. After days of debate, one idea gained traction. If the signal was ordered, then there had to be a way to test whether it came from a source capable of responding. A small group of researchers agreed to send a message back. They chose prime numbers and simple constants because those values do not depend on culture or language. Anyone anywhere with even basic mathematical awareness could recognize them. The transmission was brief, focused, and sent straight at the coordinates where 3I Atlas had last been tracked. Then the waiting began. 72 hours passed before anything changed. At first, it felt like a coincidence, but the timing lined up too perfectly. The narrow wave returned, but now the blocks shifted in sequence. Each shift matched the spacing of the primes the team had transmitted. It was not a mirror response. It was not an echo. It was a reply that showed recognition of the pattern. Scientists checked clocks, compared logs, and reanalyzed the data again and again. Every time the numbers fell into the same alignment, something out there had listened. Then a final twist pushed the story deeper. When analysts compared the shape of the new signal to known archives, they found a nearly perfect match with one of the most mysterious radio events ever recorded. The structure aligned with the famous WOW signal from 1977 with a similarity of 99% in its peak pattern. The question that followed was simple but terrifying. If the match is real, then has 3I Atlas been speaking to us for far longer than we ever realized? The next shift in the story did not come from light or radio. It came from motion. When the European Space Agency reconstructed the trajectory of 3I Atlas using data collected over several nights, the numbers refused to behave. Each calculation led to the same conclusion. The object was accelerating and turning in a way that no natural force could explain. Even the most seasoned analysts called the movement unnatural. Normally, interstellar visitors follow simple rules. They respond to gravity. They react to sunlight. They drift according to mass and momentum. If gas escapes from their surface, they may wobble or slide a little, a process known to happen when ice melts in sunlight. But nothing in the ESA model matched those ideas. There was no tail, no plume, no sign of melting material pushing the body forward. The object moved as though nothing was leaking from it at all. Teams checked the possibility of jetting again and again. Jetting would leave a signature. It would create dust or a streak of vapor. It would cause rotation. Yet 3I Atlas showed no fingerprints of that process. Its spin remained steady. Its surface remained clean.